Alright, we go to next question, question 4 in Prac 10b. So, test for convergence. Find the sum of this. So, we have to check whether this is convergent or divergent, right? You have this. So, right, this is your problem. 2020 to the power n plus 2019 to the n divided by this one 2021 to the this one here. So if you substitute, if you write 2020 instead of 2019, so definitely that term would be bigger than this number. So if you write 2020, oh wait a second. So you write 2020 to the power n instead of this bit. So what happened? So that term, this one plus this, twice, 2 times 2020 to the power n. So this term is bigger than this number here, and if you ignore one of terms, if you ignore this term, so your denominator will become very small. So that means the number is bigger than this number here. If you ignore this term, of from the denominator, so this number is bigger than that, right? I think this is clear. So this is true for all natural numbers. This statement is very important. Don't forget to write these statements, right? Very important. This inequality is true for all natural numbers, right? So here look at, notice this one. So you can rearrange this 2020 divided by 2021, everything to the power n. So what can you say about this number inside this bracket? So which is a number, this is a number which is less than 1. If so you consider number this r is equal to this number which is less than 1, then what happened to this series of Rn? This is convergent. That means when you sum this up, you get a finite number, less than infinity. You get a finite number. That's why I wrote less than infinity, right? Because this number is less than 1 and positive. This is a positive and less than 1, right? This is convergent, we call. So this series is convergent. That means if you sum this up all the way to infinity, get a finite value, right? Not infinite, infinite value, right? So look at this inequality, 2 times this one. Now you can take the summation from the both sides, right? Sum from here and sum from here. So you know that this term 2 times, you can take this out from the sigma notation. 2 times this, you know this series is convergent, then 2 times that series is also convergent. That means this one is convergent. Now we go to fifth question. Show that the ratio test fails to determine the divergence of. Alright, show that the ratio test fails to determine the divergence of this series. Alright, let's we know the ratio test, right? So take the ratio. So this is your an term. If this is a sub n term, you can find this ratio very easily. When you find, alright, this is the ratio between these two terms. Ratio of those two terms, and when you simplify that, you get something like you get something like this. So it is clear that you can simplify this, then you end up with having this one. So as n tends to infinity, what happened to this term? This goes to 0, 0, and 1 over 1, which is 1. This sequence goes to 1 as n tends to infinity. Then you cannot conclude anything. You cannot say this is convergent or divergent, right? If the ratio is less than 1, you can conclude that this infinite series is convergent. If the limit of this ratio is bigger than 1, you can say that this is divergent. But that this ratio goes to 1 as n tends to infinity, you cannot say. You cannot say whether this infinite series is convergent or divergent. Right, let's prove that this infinite series, this one here, is divergent, right? Okay. Alright, here you have factorial n squared, everything squared, divided by 2n factorial. So when you look at this term here, you can write in binomial expansion. You can write, okay, let's write this one in terms of cns, right? So you know, in binomial expansion, I think you know this notation, right? We use this for binomial expansion, right? So when you simplify this notation, right, factorial 2n factorial divided by factorial n times 2n minus n factorial, which is n factorial. 2n minus n factorial, which is n factorial here. This one here, right? So this one is one of terms of this binomial expansion. So what is the definition of, I think you know this here. So sigma k, let's take another parameter. K goes from 0 to 2n 2n ck. So this term 1 to the power k, and what is the other term? 1 to the power 2n minus k. So you don't need to write these things. This is the binomial expansion of this, right? So this one is one of terms of this binomial expansion. Then so because these are positive numbers, right? So this expansion is bigger than the single term of 2n Cn, right? This single term is smaller than this full expansion, right? So you know, it is clear that this is 1 plus 1 is 2, 2 to the power 2n, which is with 4 to the n, right? 4 to the n is greater than or equal to factorial in this one. So you can rearrange, you can cross multiply by these two terms, then you get this. So here notice this. So this term, look at our problem now. This is the problem here. And factorial squared 4 to the n divided by 2n factorial. So that is exactly here. That term is greater than or equal to 1 for all, and this is true for all integers. So all terms of that sequence an is bigger than 1, greater than or equal to 1, right? That means the limit of this one never converges to 0, because all terms of the sequence is bigger than 1. So the limit of that sequence, does not converge to 0. That means the sum of that series is divergent. This is clear.